Yes, good morning students. In the previous class we had a discussion about the oscillator amplitude stabilization in case of RC phase shift oscillator. And here one more type of the oscillator which we discussed is a bridge oscillator. Okay, so for bridge oscillator also we have oscillator amplitude stabilization network. So for any type of the oscillator you can take it may be bridge oscillator or RC phase shift oscillator, what kind of whatever the type of the oscillators you can use. So it has a amplitude stabilization network. Okay, so here also in the case of bridge oscillator also there is a oscillator amplitude stabilization network, and this is your bridge circuit. Okay, oscillatory circuit, and this is your oscillator amplitude stabilization network. Okay, so that is what once again here in this bridge oscillator also similarly when the output voltage is low, so the this is not sufficient to turn on the diodes. Okay, so in that case AV is equal to your V0 RF divided by R1. Okay, similarly there all the diodes are reverse biased when the output voltage is low. So when the output voltage is high, that is high, so then all the diodes are forward biased and it will short the R5 resistance. So therefore AV is equal to, so AV is equal to what will happens, so that is R6 divided by R1. So feedback gain of the oscillatory circuit. So this is also operation principle is similar. So by controlled switching of the your diodes we can have a stabilized output at the output side. Okay, so then another type, so the signal generator output control. Okay, so we have to control the output voltage of the signal generators. So signal generators are nothing but whatever we discussed here till now, that is a triangular wave generator, sine wave generators, various types of the signal generators we have studied. So they are the signal generatory circuits. So signal generator output we have to control here. Okay, so this is the schematic representation of controlling of the output voltage in case of the signal generators. Okay, and this is the input from the oscillatory circuit. So output of the oscillator is given to the input of this particular circuit. Okay, so here the output amplitude control by varying the feedback resistance. Two types of the controls here we are using to control the output voltage in case of the oscillatory circuits. So one is amplitude control and output DC level control. Okay, so amplitude control can be done using the by varying the feedback resistance RF. Okay, and the field so DC voltage control is done using the potentiometer at the output side. Okay, so by using these two methods, so we can control the amplitude and this one. Okay, so the output of this is given to the input of your generator output control network. So if you want to control the amplitude of the signal, so then you have to vary this RF, that is feedback resistance. So if you want to control the DC output voltage, so you have to vary this potentiometer here. Potentiometer is your R4 is your potentiometer. So this by varying this resistance of R4 we can control the output DC voltage. Okay, so to control the your amplitude of the signal, so you have to vary the feedback resistance RF. Okay, to vary the DC voltage you have to vary the your potentiometer here. Okay, this is the additional setup to have a generator output, signal generator output control methods. Okay, these are the some methods which are used to stabilize the amplitude, and some of the methods which are used to control the signal generator outputs. Okay, so that's about the oscillatory circuits. So in the oscillations we have studied about the bridge oscillators, RC phase shift oscillator, or amplitude stabilization in case of bridge oscillator, and also amplitude stabilization in case of the your what is that, RC phase shift oscillator we have discussed. Okay, so here the next part is right. Next is the comparators. So comparators and converters. So I think already we have done the experiments in the laboratories regarding the comparators network. So comparator is the main function. This is the equivalent circuit of comparator, and it's the output voltage of the comparators for inverting and for the non-inverting configurations. Okay, so comparator, the main function of the comparator is to compare the two signals, that is input signals with a reference voltage and produce the output voltage. Okay, so here in this case input is signal is given to the non-inverting terminal, that is why it is a non-inverting comparator. Okay, but the inverting terminal is given with a reference voltage. So in case of the non-inverting comparator, so the input is given to the inverting terminal and the non-inverting terminal is given with the reference voltage. That is the difference between the inverting and non-inverting type of the comparators. So both the comparators performs the similar operations which will compare the input signal with the reference voltage, okay, and produces the output. So here this is the sine wave input, okay, here it is also the square wave. It is not non-inverting type of the comparator here, okay. So non-inverting means, so whatever the positive, so you will get input is positive, output is also positive, input is negative, output is also negative, okay. So that is the what is that, non-inverting type of the comparator. So this is also the non-inverting type of the comparator for the different reference voltages, okay. So when the reference voltage is positive, this is the waveforms, okay, when the reference voltage is negative, this is the waveforms. So this is non-inverting type of the comparator circuit, okay. So the operating principle is similar, so it will compare the input signals with the reference voltage and difference amount, I mean the difference of the signals will be produced as a output side, okay. So that is the function of the comparator circuit here, okay. So when the input which is less than the reference voltage here, see here when the Vin is less than the reference voltage, the output voltage V0 will be at the minus saturation voltage. So just refer input voltage is less than, just refer here. So input is, so this is your input signal, okay, and this dotted line is your reference line, okay. So so when the input is less than the reference one, so if the input signal which is below the reference line, so the output will be at the positive saturation, okay. Similarly, if the input is, okay, above the saturation level, so input reference voltage is greater than the input voltage is greater than the reference voltage, the output will be at the negative saturation here, okay. So that is the difference here. See here, this dotted line is reference line and sine wave is your input. So in the first case, what is the input will be, so from here to this line you take, so there is a input is less than the reference line, so you will get the positive saturation voltage. So when the input is more than the saturation voltage, reference voltage, then the output will be at the positive, in the first case, that is Vin is less than V reference, so the output is at the negative saturation, so that is negative saturation. When the input voltage is more than, greater than the reference voltage, then the V0 will be at the positive saturations. This is vice versa. So when the input voltage is less than the reference voltage, so the output will be at the negative saturation. When the input voltage is more than the reference voltage, then the output will be at the positive saturation. That is the difference in case of this one, okay. This is what we studied here. This is the non-inverting type of the comparators. So the inverting type of the comparator, the operating principle is also similar. So only the thing is, the input is applied to the inverting terminal and the non-inverting terminal of the comparator is connected to the reference voltage, okay. That is the difference. So the next comes is a zero crossing detector. So this also already done in the laboratories. So zero crossing detector. So the another most important applications of this comparator is zero crossing detector, okay. So there are various types of zero crossing detectors we have. So inverting type of the zero crossing detector, non-inverting type of the zero crossing detector, capacitor coupled zero crossing detector. These are the three types of the zero crossing detector circuits here, okay. So this zero crossing detector explained with the help of this equivalent circuits and the related waveforms, okay. Zero crossing detector, the main function of this zero crossing detector is to detect the zero crossing of the input signal, okay. It is also a basic operational amplifier. So it is a non-inverting zero crossing detector. Why? Because input is given here to the non-inverting terminal and the inverting terminal is grounded. That is why it is a non-inverting zero crossing detector. So this is a sine wave is your input and square wave is your output. So the function of this zero crossing detector is to detect the zero crossing of the input signal. Whenever the input signal crosses the zero line, it produces the square pulse, okay. See here, so here at the zero, okay, and it is crossed 0, once again the square wave is produced. So once again it crossed the 0, square wave is produced. Okay, so the main function is to, when the input signal crosses the 0 line, it will detect and produces the pulse. That is the main. It may be input, may be sine wave, or ramp wave. So irrespective of any type of the input, whenever the input crosses the 0 line, it will detect and produces the pulses. Okay, so it is non-inverting zero crossing. So inverting zero crossing detector, it is once again simple. So the input is given to the inverting terminal and the non-inverting terminal is grounded here. Okay, that is the difference between the inverting zero crossing and non-inverting zero crossing detector. See here, this is the also it is positive input, the negative output, negative input, positive output. Why? Because it is a inverting type of the ZCD, zero crossing detector. Okay, so that is the function of zero crossing detector here. Okay, so that's about today. The rest of the things we will take up in the next class. Okay, thank you.